Imagine, every year, the world produces over 108 million cubic meters of particle board, recycling 16 million tons of wood waste that could have just rotted in landfills or been burned. This isn't just a material, it's a recycling revolution. From old packaging, offcuts, and even used furniture to the sturdy foundation for your cabinets, tables, and shelves. And did you know that 25% of this production is already certified as environmentally friendly? In this video, we'll uncover the secrets of this industrial marvel. From giant chippers that swallow logs to hot presses where resin creates a monolith. Find out how waste is brought back to life in the three-layer sandwich of a perfect board, and why this is the future of sustainable design. Ready for a journey from trash to masterpiece? Don't look away. Every step will mesmerize you. It all begins at a huge raw material yard, where the foundation for the future particle board arrives in a continuous stream. This is a place where the idea of rational resource use is brought to life on an impressive scale. Contrary to popular belief, high-quality commercial timber is almost never used for particle board production. Instead, the production philosophy is to give a second life to wood waste, turning what was previously considered a byproduct into a valuable material. Piles of raw material, reaching tens of feet high, are brought here. The base is technological chips, obtained from low-quality wood that is not suitable for lumber production. A huge share consists of waste from sawmills. Slab wood, which is the side parts of a log with a rounded surface, board offcuts, and thin strips that remain after log cutting. Woodworking waste, such as shavings and sawdust generated at furniture and carpentry factories during planing and milling, is also actively used. A separate and important direction is secondary wood. Old wooden pallets, crates, packaging, and even used furniture, after a thorough cleaning process, get a chance for a new life as part of a particle board. Every batch of incoming raw material undergoes strict incoming inspection, as purity is the key to quality. The first stage of cleaning is the removal of metal inclusions. Powerful electromagnetic separators, capable of pulling a steel bolt from a distance of several inches, sift through the stream of raw material, removing nails, staples, and any other metal fragments that could catastrophically damage the expensive shredding equipment. Next, the raw material passes through screening systems to remove mineral impurities, sand, stones, and other debris that act as an abrasive and quickly dull the cutting tools. If whole logs are used in production, for example, 20 feet long, they must pass through a debarking machine. In a huge rotating drum, or with the help of special cutters, the bark is removed from them. This step is critically important, as bark has a different structure, contains a lot of dirt, and significantly worsens the quality of wood chip bonding, as well as negatively affecting the appearance and strength of the final product. The prepared and cleaned wood begins its journey on a conveyor belt hundreds of feet long, which relentlessly carries it to the first stage of mechanical transformation. It disappears into the steel maw of a giant chipper, an industrial monster the size of a small room, capable of swallowing pieces of wood several feet thick. Inside this machine, with a deafening roar that makes the workshop floor tremble, a massive disc equipped with razor-sharp knives rotates. Rotating at a speed of thousands of revolutions per minute, these knives cut into the wood with incredible ease, turning whole pieces into a stream of uniform chips a few inches in size. But this material, despite its uniformity, is only a semi-finished product. The resulting chips are too large, coarse, and non-uniform in shape to create a quality particle board. Their cubic structure would not allow for the creation of a dense and monolithic structure. Therefore, the next step is a finer and more delicate secondary grinding, which takes place in specialized flakers or mills. It is here, in the hum of high-precision equipment, that the very particle that gave the final product its name is born. At this stage, the geometry of the chip becomes crucial, as it is designed with engineering precision. For the outer, face layers of the particle board, which will be responsible for its appearance and smoothness, very fine, thin, and flat flakes are needed. They are produced in knife ring flakers, which literally shave thin flakes from the chips, resembling flakes only a few hundredths of an inch thick. These flakes, having a large surface area, perfectly bond with the resin and form a flawlessly smooth surface, ready for further processing. In contrast, for the inner, central layer of the board, which is its structural backbone, larger and thicker flakes are used. They create a strong internal frame that gives the particle board its final rigidity, bending strength, and the ability to securely hold fasteners, such as screws and bolts. The resulting chip mass has varying moisture content, which is unacceptable for quality bonding. Therefore, all the chips are sent to one of the most important stages, drying. Usually, huge drum dryers are used for this. The chips are continuously fed into a rotating drum, where they are blown with hot air or flue gases. The process is strictly controlled by automation. The final moisture content of the chips must be in a very narrow range, from 2 to 6%. If the chips are over-dried, they will not be properly saturated with glue. If they remain too moist during hot pressing, the excess water vapor can rupture the board from the inside, forming defects. The dried chips are not uniform in size. To create the correct 3-layer structure of the board, they must be sorted. The chip mass passes through a system of mechanical screens or air separators. Heavier and larger chips, intended for the inner layer, settle first. The lighter and finer fraction for the outer layers flies further. This process allows for obtaining 2 or more streams of chips of different geometries, which will be used to form the sandwich of the future board. Now it's time for the key component that will turn the loose mass of chips into a monolithic board, the binder. Most often, these are synthetic resins, mainly urea formaldehyde or melamine urea formaldehyde. The sorted chips enter special continuous mixers. Inside them, the resin is sprayed through nozzles, creating a glue mist that evenly envelops each particle of wood. The dosage of the resin is critically important and is usually from 6% to 10% of the mass of dry chips. Along with the resin, other components may be added. The resinated chips, now sticky and ready for bonding, are finally ready to become a board. They are transported to a massive forming machine, where a continuous chip mat is born from the scattered particles. It is here that the engineering magic of creating a 3-layer structure takes place. The forming machine is a complex system that sequentially and with high precision sprinkles chips onto a moving conveyor belt. First, it creates a perfectly even bottom layer, using the smallest fraction of chips. Immediately after this, a much thicker middle layer, consisting of large and strong chips, is laid on this base. Finally, the entire mat is covered with another layer of the fine fraction, creating a mirror image of the bottom layer. This carefully designed structure, resembling a sandwich, provides the unique properties of the future board. Its smooth and dense outer layers are ideal for further sanding and laminating, while the strong inner layer gives the board the necessary rigidity and the ability to securely hold fasteners. The formed but still loose mat passes through a pre-press, where it is significantly compacted. This pre-pressing removes excess air from it and gives it a shape convenient for loading into the main press. This is the culmination of the entire technological process. The pre-pressed and cut into fragments of a given length mat is fed into a hot press. This can be either a giant multi-opening press of periodic action, which simultaneously compresses a whole stack of boards, or a modern continuous press of the belt type. Inside the press, the chip mass is simultaneously affected by 2 powerful factors. Huge pressure, reaching tens of kilograms per square centimeter, compresses the chips, leaving no voids between the particles. At the same time, the press platens, heated to a temperature of 400 degrees Fahrenheit, transfer their heat to the mat. This high temperature activates the resin, launching an irreversible polymerization process. The liquid glue instantly turns into an extremely hard and strong polymer, which permanently glues millions of wood particles together. The time spent in the press depends on the thickness of the board and usually lasts only a few minutes. During this short period, the loose mat turns into a hot, hard, and absolutely monolithic particle board. The hot boards after the press cannot be stacked immediately. They need to be cooled gradually to relieve internal thermal stresses and avoid further deformation or warping. For this, they are placed in special stair or fan coolers, where they are blown with air for several hours until they are completely cooled and their structure is stabilized. The next step is calibration and sanding, which gives the board a marketable appearance. The boards pass through sanding machines with several heads, where wide abrasive belts remove a thin surface layer, bringing the board to a precise specified thickness and creating a perfectly smooth surface. At the final stage, the large technological boards are cut into standard commercial formats, and their edges are trimmed. The finished product undergoes strict quality control, where its density, bending strength, moisture content, surface quality, and dimensional accuracy are checked. Only quality boards are marked and sent to the warehouse. From there, their path lies to furniture factories, where they will be transformed into familiar household items, silently demonstrating the amazing journey from unnecessary chips to a functional and indispensable foundation of our comfort.